C'est bon, c'est bon. Normalement, vous pouvez commencer.
أعطينا le partage تاع l'écran. Allô?
C'est bon, c'est bon.
Ok, parfait. C'est clair, Dakar, est bien l'écran? Allô?
Non, on ne voit pas votre écran.
Donc, c'est clair, hein?
Oui, oui, c'est bon.
Ouais,
Ok.
c'est bon.
Bon, مساء الخير, c'est M. Haddad Brahim, docteur, chercheur à l'unité de développement des équipements solaires à l'UDES Besmaïn. Donc, l'intervention راح تكون على planning of renewable energy. Donc, c'est la transition énergétique. Bon, on commence. La présentation, it will be start by introduction. After that, we have an overview about economy and
Allô? C'est un souci d'Internet, je pense qu'il va revenir dans quelques instants.
Allô?
Allô?
Oui,
On
désolé,
un petit moment.
c'est l'Internet. Désolé.
J'avais compris, il n'y a pas de souci.
So, sorry. So now we will talk about the electricity production in the worldwide. It will be increased by 69% by 2040. So the production of electricity in the worldwide is responsible about 42% of global emission of CO2. So according to some studies about the transition of renewable energy, the renewable energy is a very benefit for Algeria and can provide a lot of benefits, such as diversity of production by using the multi-source of energy. And other studies of German researchers, so they said that if the North Africa can export the energy to Europe only if the production of electricity surpass 60% of the total demand. So Algeria have different and many challenges, such as rapidly growing population. It's around 2% really. And also we have slow economic growth. And also another challenge, increasing rates of unemployment. And finally, we have a significant environmental pressure. So we have to surpass this challenge by integrating the renewable energy program. Challenges are global and regional issues such as climate change and geopolitical tensions. So Algeria is exporting fossil energy. We are a fourth largest country exported liquefied natural gas. And also we are a third large country export liquefied petroleum gas. Also, we are a fifth largest global exported of total natural gas. Algeria also is ranked as a third country of potential of shale gas in the worldwide. For the case of Algeria, the energy consumption of Algeria is growing rapidly, and it's around 1.7% in 2014. Also, now we don't have this problem, but in the past, in 5 years ago, we have problem of importation of gasoline and diesel. Now Algeria is producing gas and gasoline. So if we see the internal energy consumption of Algeria, it's high and it's growing rapidly. The sector of residential is the most consumer of energy. So we have a high energy consumption by the residential sector, followed by transport sector, and finally by the industrial sector. So the industrial sector is the last or the most the last sector of term of energy consumption. Also, if we see the GDP, which means a BIP in French, with price of oil, we see that it's similar curves. Curves of the both parameters are very similar, which means that the GDP of Algeria is highly affected by the price of oil. So also the energy production in Algeria, the electricity sector, is mainly based by the natural gas, around 69%. And we are using cycle combine as the main technology to produce the electricity, followed by gas turbine and steam turbine. All these technologies are using a natural gas. And then we have DSL in the isolated area in the Sahara, and followed by hydropower in the dams. And finally, we have small contribution of renewable energy, which is PV and the wind, and CSP, which is a hybrid central power with CSP and steam turbine in the Hasirmal area. As we can see, the energy consumption, the electricity production is mainly based on natural gas, and this is a problem. So 96% of the total installed power is from the natural gas, fossil fuel, and renewable energy technology is only about 2%. This is a big problem because we have energy model is not diversified. The program of renewable energy of Algeria. So we have an ambition program, the government launched an ambition program, which around 22 gigawatt from the renewable energy, and energy efficiency program, which is main with renewable energy program. It's the efficiency program can avoid to install around 1,500 megawatt. So if we applied the measures of energy efficiency program, this program can help us to avoid around 1,500 megawatts. Also, we have another program which is very important. It's around 2 gigawatt from the nuclear, and it's very important program which will be used to produce the electricity and also fresh water. So the program of 22 giga of Algeria is mainly based in the photovoltaic. It's around 62% from the PV, and we have 22, or we can say 23% from the wind energy. And after that, we have 9% from the CSP, solar concentrated power. And finally, we have a biomass and geothermal and the cogeneration. So this amount of energy can produce around 33% of electricity by 2003. So if we install this program, it's allowed us to produce around 33% of the total electricity production by 2030. Unfortunately, the program was reduced. I don't know why, but the government reduced the program of 22 giga to 15 gigawatt and we go to 2035. We don't know the capacity of each technology. Until now, the government don't give the details of the program, but I think it will be the same as the 22 gigawatt. It will be based in photovoltaic technologies. So we will also present the program of efficiency, energy efficiency. The energy efficiency target 3 main sectors, which is building, it means residential, and the transport sector and industrial sector. So the building sector, which means residential, the government want to install around 100,000 thermal insulation. In the program of ADL, the government planned to install to isolate the apartment insulation, thermal insulation per year, but the government don't do anything until now. We have also installed solar water collector, the chauffe-eau solaire, around 100,000. It's the similar number of insulation thermal of building. And we have also replacing the lamps, the classic lamps, by low consumption lamps per year, around 10 million lamps. Also in the transport sector, the government also want to convert around 1.3 million cars from the gasoline to LGP fuel. And also we want to convert around 11,000 of buses to use compressed natural gas, and also buying new buses, around also 11,000 buses. In the industry sector, the government tried to create audit energy. The audit energy can give orientation to the industry to use equipment, efficiency equipment, to limit the energy consumption of electricity, and also give plans to change the way of energy consumptions. So in the street or in the public light, the government also want to replace the lamps, around 1 million lamps. So in the fossil energy and the nuclear program, around the 27,000 megawatt will be installed for the period 2015 and 2025. We have also another program of nuclear energy, around 2 gigawatt from the period of 2025 and 2030. As we know, Algeria have a great potential of uranium, around 26,000 tons of uranium. So our subject or our thematic is talking about multi-criteria decision making. Multi-criteria decision making, it's approach used to make decision, but we also in energy, we can use it in energy. So what it means? It means how we can make a decision to use energy or to use technology to produce electricity. So this approach was used by the Army of United States. Was used to find the water resource. So it's building by hierarchy. To first of all, we have to specify the problem and make the inventory forecast and formulate the plans. After that, evaluation. After that, comparison between different alternatives, and finally make the ranking or make the decision. So this method were used by the Army to find water and related land resource problem. This is example of Army using a multi-criteria decision-making approach to find or to solve the problem of water. So we have also inventory forecast and analysis of water related to land resource condition with the planning area relevant to the identified problem and opportunities. We have also formulate of alternatives plans or scenarios. And then we have evaluation of the effects of alternative plans. And we have comparison between the alternatives. And finally, make the decision or recommendation or classification. So we can use a scenario. We have different approach of scenario, different type of scenario, predictive scenario, explorative scenario, and the normative scenario. The scenarios are used to analyze the different problems can happen in the future and preparing plans to tackle or to face this challenge or problems. So we have to make a decision. Decision in the energy is important. Most of the time or frequent approach use, it's AHP. I think you heard about it. It's analytic hierarchy process method. It's used in the management also. So this approach is classified in 3 steps. First of all, we have to define the problem and determine the goal. Construct hierarchy diagram problem using a multi-criteria decision making. And after that, we have in the hierarchy diagram, goal, main criteria, sub-criteria, and alternatives. And then we have to consult expert. And after we have feedback from the expert, we can make the comparison between the alternatives. And after that, we use some mathematical equations to get the final rank of the alternatives. This method was proposed by Sati in 1977, and it's very used in the energy problem. So this is matrix. We have the C1, C2, and etc., which is alternatives. And in the matrix, we have the comparison matrix between different main criteria, sub-criteria, and alternatives. And after that, we have some equations to make the combination and get the final rank. So we will talk about energy. Usually, we have 4 main criteria: technical criteria, economic criteria, and environmental and socio-political. Each main criteria involved different sub-criteria. We have a limited of sub-criteria, which can be used according to the specific problem. For example, Algeria is different than Europe. Europe is different than America, and so on. So it depends on the specific problem. So as an example, we did the work with a Portuguese laboratory and the Portuguese researchers and build some energy model for the case of Algeria. For example, here we have 4 main criteria, and each sub-criteria, and in each main criteria contain different sub-criteria. For example, in technical criteria for our case, we have technology maturity, which means that if this technology is mature to be used at the national and international scale. We have also another criteria, which is safety and reliability and energy production. This is only for a case of Algeria, and we made the selection according to the problem of energy of Algeria. Another main criteria is economic. We have the total cost or investment cost, and we have operation and the maintenance cost. We have also life service and a payback. And the environmental criteria, we have another sub-criteria, which is impact on ecosystem, a potential for reduction of a greenhouse, which means if we install renewable energy, how we can avoid CO2 emission, how much of CO2 emission will be avoided. We have also in the socio-political main criteria, social benefits, social acceptability, and political acceptance. This case or this model or this example is only for Algeria. So we can find another models which is for different cases. So as a result, we have for first main criteria comparison, we have the environmental criteria, main criteria, which is very important, around 33%. And we have socio-political criteria, followed by technical and economical. This judgment or this ranking was made by expert. So we consult expert, and after that we get some feedback, and the feedback will be transformed in numerical scales, and after that we get the final ranking. So after that we have this graph of the sub-criteria, and this graph shows the importance of each sub-criteria. In our case, we found that the impact on ecosystem, is the most important, followed by investment cost, total cost or investment cost, and social benefits. Because in Algeria, we care a lot about social problems. We have the final ranking of the different alternatives. We have the solar energy in the first, and the wind in the second, biomass third, and the last, we have geothermal and hydro. So another example of the selection of the most important location for CSP or for renewable energy. So with this example, we did it with Spain, with the University of Sevilla in Malaga, near to Malaga. So what we did, we made a mapping of best location of renewables energy. So this model is classified or is in the 2 steps. We have to calculate the mapping of an adequate, no adequate site or no adequate area, and after that we got the adequate area, and the adequate area is classified from the best to the worst area. We can see the example after. So to solve this problem, it means how we can where we can install the power plants of renewable energy. which are the most adequate or the adequate area for power plants of renewable energy. This problem is also classified by main criteria and sub-criteria. We have a problem of climate, which is solar radiation. We have topography of the site, which means slope and slope orientation. We have also the location of the site, distance to population, density population, and also distance to road and railway, and distance to electricity grid. This is very important criteria. And finally, we have water resource. In the power plant, we use water to cool the power plant. So we have distance to waterways and distance to dams. As an example, we got the best area for the wind and for PV and for CSP. So the first one is for the wind, and after that we have the smallest maps for the PV, photovoltaic, and the wind, and in the right we have the CSP maps. As you can see here, it's with the color is classified from the very low to very high suitable area. It means the best area to install a power plant for renewable energy resources. So how we can make our strategy and implementation of the power plants? We have to take into account the current status and trends, and also a total energy security and plans. So, although the country is an energy producer, we produce fossil fuel, but we have problems and difficulties to meet the energy demand, energy demand. And we also have problem to export gas. Algeria also have another problem is to meet the energy security and climate change goals. So we have many problems. Therefore, a clear understanding of socio-technical interdisciplines in the energy system is important to make our strategy. Also, we have to involve the stakeholders in the decision making. So the transition to energy system based on renewable energy is a promising way to meet this growing energy demand and also to reduce greenhouse gas emission, and also to increase economic growth and the local environment and reduce fiscal constraint. Transition towards renewable energy based in the system involves large-scale deployment of renewable energy technology. It means that we have to make strategy for large scale of renewable energy, and also development of infrastructure and implementation of appropriate regulatory framework, and creation of new markets and industry. Here we have some work and papers published in this area. As we can see here, we don't have too much works in this area, unfortunately, and we don't have too much data about the investment in the renewable energy. Thank you for your attention. And sorry for I'm a little bit confused. Hello?
Allô?
Allô, oui.
Oui, super. Bah, écoutez, merci beaucoup. On va laisser la parole aux participants s'ils auraient des questions. Lamine?
يعطيك الصحة على لا بريزونطاسيون، مي عندك بروبليم تاع كونيكسيون شغل لاشينا شوية.
اوكي.
Pas de souci.
احنا نقراو سبيسياليتي واش كنت تكسبليكي تما. يعطيك الصحة، ميرسي.
ويلكم. Allô?
Allô? Oui, allô.
Oui.
Donc, n'hésitez pas si vous avez des questions. En tout cas, nous, on est en contact avec Monsieur Haddad. Donc, même si vous aurez des questions après, ou même pour les personnes qui vont voir aussi l'enregistrement des workshops, qui auront certainement des questions tout à l'heure, euh, qui ne sont pas maintenant parmi nous. Donc, voilà. Je pense qu'il n'y en a pas avec ceux qui sont ici. Parfait. Ben, écoutez, merci beaucoup. Nous allons repartager de toute façon le workshop avec les autres participants afin de revoir la conférence sur cette thématique-là, qui est la transition énergétique, les énergies renouvelables et aussi l'énergie verte. Et voilà, donc s'ils ont des questions, je vous les transmettrai directement et
OK.
afin de répondre aux différentes questions.
OK. Parfait.
Ça
Noor,
marche, ça. Oui, oui,
I
Aïcha.
just want to say thank you so much for this presentation. We enjoyed it, and I promise you we will take care of all this information you gave it to us. Thank you so much, sir.
You're welcome.
Merci beaucoup, Monsieur Haddad.
You're welcome. Thank
Merci
you.
beaucoup. Merci beaucoup. Donc, je pense qu'on peut... Allô?
Oui, oui, نسمع فيك.
Roa, s'il te plaît, tu peux me rendre animateur. Allô, Roa. Allô, allô, Roa. Kauter, Karimo, vous voulez qu'on commence maintenant? Alors, je connais maintenant, je connais 18h30.
احنا نبداو دوكا احنا.
Ok. Kauter, 18h, ça t'arrange? Allô, Kauter. Ah, ça t'arrange.
Oui, oui.
Oui. 19h30, c'est OK pour toi? Ah, 18h30.
18 oh, oui, ok, ماشي بروبليم.
هيا خلاص ما نعاودو لي برك في لو ليان 18h30.
يا بيان.
نور
Oui, Roa.
رانا رديناك سي بون.
هيا super parce que ah non, il est برك animateur s'il te plaît. Parce que là tu es en train d'enregistrer.
Salut. D'accord.
Bien, ça va?
Ça va, alhamdoulilah, نتوما؟
Ça va. Ah, je pense que c'est Karim qui est animateur.
Oui, oui, ça y est, donc راني مع كريم دوك رجعت. سي بون.
Juste arrêter. Ah, c'est bon, ouais, super.